Okay, so I work for the SPC, and I'll talk about what SPC is a bit later because I had a few questions today, what actually SPC is and what its mandate is. So my talk today would be on Digital at Pacific. It's sort of a program, a very early program that we started a couple of years ago, trying to replicate the success of Digital at Australia and Africa. And the point of the talk today is how we are using Earth observation at scale to make the Pacific islands and territories more climate resilient. Yeah? So it'll be more focused on climate than anything else. So SPC is the principal scientific and technical organization in the Pacific. We are owned and managed by 27 member countries, so everything in the middle of the Pacific are the countries that we're active in. We have about 800 staff across 5 countries. Most of them are based in Fiji. However, our headquarters is in New Caledonia, Numia. We have 8 technical divisions, and you can see the domain areas that we're active in. So we work in FAME, which is fisheries, education assessment, human rights, stats, public health, land resources, climate change. My division in particular is called the Geoscience, Energy and Maritime Division, and we're active in ocean science, marine transport, energy, georesources, disaster risk resilience. And my program, finally, is called Earth and Oceans Observations. So that's a bit of context for those who asked this morning. So we all know what Earth observations is, right? I mean, we are all GIS experts. But the point I would like to highlight here is that compared to traditional remote sensing, where we're only looking at changes that happen in the point in time, Earth observations is all about monitoring changes, tracking changes over time. So data analysis on a temporal scale, not just a spatial scale. So that's probably pretty much, it's a very important fact to remember because a lot of people ask is, hey, what's the difference between remote sensing and Earth observations? Yeah. And another point to highlight is Earth observations is not just about satellites. It's also dependent on in-situ data, calibrated data, field data, and of course other sensors like drones and LiDAR. So why all the fuss about EO in the Pacific? So as you know, we have data capture fortnightly, weekly from likes of Landsat and Sentinel for the last 30 years. And while developed countries like AU, NZ, and US are easily able to access this data and do analysis and build climate models and monitor changes around infrastructure, disaster resilience, the Pacific Island countries are not super rich, so we don't have the technical capacity or the infrastructure or the skill sets to easily harness these decades and decades of data, right? So something that's doable now in your laptops, it's not entirely feasible for us because of limited infrastructure and skill sets. So at Geo Week in Brisbane in 2019, a bunch of Pacific leaders got together at the group of Earth Observations conference, and they said, hey, we have to do something about it. We have to really look into how we can utilize Earth observation and have one-to-one parity with more developed countries. And they mandated SPC to start exploring such a system because they were really impressed with what Digital at Australia was doing and what the Africa platform was doing, which both of them were developed by GA. And they wanted EO to solve the major challenges facing the Pacific. So again, as you know, we face significant challenges from sea level rise, climate impacts, food insecurity, and disasters. So after we got the marching orders from our members, we started talking to a few countries in 2020. Unfortunately, that's when COVID happened, so we couldn't actually have very wide-ranging consultations, so we had to be very particular about the countries we talked to. So we talked to 4 countries. So Vanuatu and Tonga we chose because if you look at the World Bank World Risk Index, the countries most at risk from climate and disaster impacts, Vanuatu is number 1 and Tonga is number 2. And then we also talked to Marshall Islands, which is a very small atoll-like nation, which is severely impacted by coastal inundation and sea level rise. So after talking to these countries and a few others, we put out a report, the Digital at Pacific Needs Assessment Report. Again, mind you, this is even we have started building an infrastructure. This is just talking to countries. We don't even know what's possible or what we can achieve. So the needs were quite clear. They wanted things like land cover change. They wanted coastline change, agriculture, crop census, And on the disaster sides, they wanted to monitor things like cyclones, tsunami, droughts, and of course mangroves, which is very important for climate resilience and climate adaptation. So once we knew what we had to do, we started building things. So Brianna highlighted this earlier. Earth observation should be a common good, it should be a public good. So we were very clear going ahead that whatever we do should be publicly available and should only use and output free and open data. So using things like Sentinel and Landsat. And the digital public infrastructure should be available to all the member countries without any cost involved. Yeah, so we had very clear principles going ahead before we started writing code, I guess. So I'll go more about the architecture later, but at the moment, it's an analytical cloud platform that makes remote sensing analysis IRD accessible via well-defined standards stack and enables users to perform highly scalable EO tempo spatial analysis using open source data science libraries and models. So very clear workflow, but we are quite mindful that we are not building products just for the sake of products. With all these observations, we want our products to align to our SDG goals and our different strategic documents that we have in the Pacific. So everything we do is aligned to solving some kind of decision-making for sustainable development. All right, so again, this is not something that we're doing on our own. We are trying to replicate the success of Australia, Africa, the Americas, and a few others popping up in the South Pole. Yeah, so we're very glad to be part of the community. And we thought it would be quite easy to just copy and paste what they're doing, right? It wasn't. So again, you have to understand, this is a snapshot from 2020. This is not what Open Data Cube is right now or Google Earth Engine is right now. It was the state of things when we started. One of our biggest challenges was that we wanted things to be compatible with stack because that was an industry standard that enabled us to not host data ourselves, which will be unfeasible because we're talking about 22 countries with large ocean states, but plug into data sources from authoritative sources, like, for example, Sentinel or Element 84 or NASA, and do analysis because it'll be too cost prohibitive for us to store and manage petabytes of data and also have the real-time downloading and IRD processing and all that. Open Data Cube was good. We had the first prototypes were in Open Data Cube, but because of stack, we chose not to use Open Data Cube. And so this is something we regret deeply. Google Earth Engine, the challenge with Google Earth Engine was we have a lot of in-situ data, legacy data, satellite images, aerial photographs, LiDAR, that we wanted to embed in our analytical workflow. So Google Earth Engine didn't make that feasible. We have to work with what's there. And again, it was not stack compliant. And then around that time, mid-2020, DevSeed and Microsoft started talking to us and they said, hey, we are putting up this planetary computer thing that's in beta, but you guys can start using it. And again, one of our core principles was that we wanted everything to be open and there should be no vendor lock-in. And so we were quite hesitant to partner with Microsoft on that, but they did say that, hey, you can actually deploy the analytical hub on your own environment. So we were not dependent on Microsoft. We just took that technology stack, which is basically Pangeo containers, and Jupyter Hub, and then we deployed it in our own cloud environment. The only thing that we were reliant on Microsoft was their data hosting. So they do a lot of data processing done by Esri and a few others that's hosted by Microsoft Planetary Computer, and they have a very well-defined stack catalog, not just like Landsat and Sentinel, but also climate models and rainfall data and whatnot. So it was a very, very sexy proposition for us. MSP, Microsoft, yay. Yeah, but then, as you know, Microsoft is pulling resources from Microsoft Planetary Computer. And we found about it in mid last year or late last year, and then we actually started moving away from using Microsoft components. So Alex got on board mid last year, June 2023. Thank you, Alex. And he started looking at how we can do a clean room implementation in AWS. So without any dependencies on any cloud provider or any data provider. And before that, we had worked with the likes of Development Seed to help us maintain the analytical hub, our own instance, which was not very easy. So it's a very complex bit. But I think what Alex has done now, I have a few slides later, I think it's a bit more cleaner and streamlined deployment of what a data cube should be. All right, so again, Paul doesn't like this slide. Again, this is a snapshot of what Digital at Australia was in 2010 when they started, and what Africa was in 2020, and what we are now. So there's a lot of things that we have now, which is, again, available across all the Open Data Cube deployments now. But for us, I think it was the first ones that we did this, was the level 1 RTCs. The stack was not just consuming stack, but also exposing all our products as stack APIs, so anybody can use it and download it or visualize it. And then I think we've also done a few innovative things around GeoMage and whatnot. Thank you. All right, so this is what it looks like. It's very simplified. There's a lot of other moving parts here, but at the moment it's hosted in AWS in US West, because that's where all the data is. Before, our deployment was in Europe, so that had a bit of a performance challenge from bandwidth side of things, but I think things are super fine now. And we use a Frankenstein hybrid mixture of Pangeo and Open Data Cube libraries. So we are not tied to anything particular. I know Open Data Cube ecosystem is really evolved because they've been doing this much longer than things like X-Array and some of the other helper libraries like Rastrio. So we just use what seems fit for the purpose. And then on top of that, we've also built a lot of abstraction tools like DevTools and DeepAL that we use for capacity building, which I'll talk about later. On the visualization side, we are at the moment still, unfortunately, using GeoServer, but we want to move to Odyssey OWS very soon, 2.0, when it comes out. And we also use StyleServer for vector datasets like coastlines. And everything's stack compliant, and we use Argo to run things at scale. But as I said, like, we are gradually moving towards Open Data Cube because it's very well supported, and it also integrates, have native integrations with other Pangeo compliant libraries now. And again, the primary thing is that Microsoft investment in tools seems to have died up. So there were like a few bespoke libraries that was built on top of Pangeo by DevSeed and Microsoft that we don't know if will be maintained in the future. So I think it's best to bet on horses that you know have investments and funding. Yeah, so we're just waiting for 2.0 that Paul will talk about in his next presentation because we have some showstoppers like anti-meridian and dateline issues and rand and whatnot. So once that's sorted, then we can finally move. Okay, so that's the technical side of things. Now I'll talk about products and the value. So the way we talk to donors, because like to do things at scale, you need money, right? And so we have to depend on reports like this. So one of the critical reports that we looked at was the Digital at Africa's a report that came out in 2021 about unlocking the potential of Earth observations. So it says that with a $7 million per year investment, the African nations are able to contribute back $2.3 billion back to the economy. So figures like this, it's a huge impact. And then there's another study that came out in May 2024 by the World Economic Forum, and they said that Asia Pacific, our region, is poised to reach a potential value of $315 billion in sectors like agriculture, mining, supply chain, and government services. And I really like this tweet, even though it has no relevance, is that came out in May by Geo that the Earth observation data, not the infrastructure, the services data itself will reach about 700 billion by 2030. But the key thing to highlight here is that it's not about the money, right? All these dollar values translate to real world impact in how we solve challenges around climate change, how we understand and protect the planet, how we solve food insecurity. So yeah, exciting days to be in the Earth observation field. Okay, so we got infrastructure in place, we got some funding, we started building things, and we went back to our needs assessment report, and we started building products. So at the moment we have 22 years of Pacific coastline change. One of the interesting facts that we found out that when we generated the 22 years of coastline for every single island and atoll in the Pacific, it equated to 10% of global coastlines. So all that little islands and atolls in the middle of the Pacific that we overlook, or not even the atlas sometimes. If you combine them together, that's about 10% of global coastline. So that was a very exciting fact that we found out. Again, because nobody had done that before, right? So, yeah. We have 7 years of mangrove data, mangrove health and density, which is very important for climate adaptation. And then for drought and flood, we have water observations from space. So most of these products were already developed by GA. We tried to adopt their methodology as much as possible, but there were a few challenges we'll talk about later. And of course, like we have been talking about these kind of figures for a while now. To buy a Landsat image 10, 20 years ago was $10,000 per tile or something, but now everything's free, thanks NASA. So we are able to do this in a very cost-effective manner without paying billions and billions of dollars. If we did build the infrastructure ourselves and the data, just to do these 3 regional products will cost about $450 million, because you have to look at the scale and the amount of data that we work with. All right, so when we did the Pacific coastlines, and again, this is a very impactful product for our leaders, because when we go to meetings and so ministers, the coastlines product, they get actually emotional. They have like tears in the eyes. So this is Solomon Islands, and you can see in just 20 years, we have lost half a kilometer. Yeah, so it eroded half a kilometer, 476 meters. And you'll see a lot of these islands split into 2. We think of coastal processes as long-term change, but in the Pacific, things change within 10 years, yeah? Even like you'll see a lot of black lines. The black lines are the older years, and the lighter lines are the new years. So the black lines means there was an atoll or landmass there that has disappeared over time. Yeah, and this is just one example. You can go to all the 27 countries and look at many more examples, or you can come to the booth and we'll show more examples. So because the Pacific has a unique problem of scale not in the terms of large scale, but small scale. So when we tried to adopt most of the things that was done in GA, especially with the coastlines, we quickly found out that it was not suited for our very small, tiny dots of atolls and islands. So this is what the initial product looked like on top. You can see a lot of noise based on surfs, based on different kind of landmass. So what works in Africa and Australia in terms of the geomorph is quite different from what works in the Pacific. So we had to do a lot of extra additional work in terms of automating cleanup, doing surf removals, exploring different kinds of automated water extraction indexes to see what works. And then after that, once we cleaned that up, then we started building rates of change, because this is more useful for countries. So for example, if you look at this place here, you can see it's been eroding for the last 30, 20 years, and there's a village here. So a minister can quickly say, hey, no, we probably need to relocate the village because it's at risk of inundation because of sea level rise and coastline change. We also have mangroves. There's a video here, maybe I won't play it. So mangroves is quite simple. We just measure the density. 2 minutes? All right, I was just getting started. All right, so yeah, you have water observations of space to monitor drought. This is in PNG, before and after El Nino, when the drought happened. So you can see how flood zones change and how water bodies change over time. Very important for disaster risk impact. All right. We also do a lot of other work around illegal river extraction and mining, detection of mining. Because the countries don't have capabilities to monitor everything using drones. So we have these early detection tools. And my colleague Nick will give a presentation on that this afternoon. So if you are interested in Earth observations and illegal mining, it's an exciting topic, then you can attend that presentation. Yeah, we have other products like GeoMed, which is, we have a lot of challenges around cloud cover. So if you look at the graph on top, out of 12 months, we only get 8 months of imagery for big countries like Vanuatu. So even if we do things like cloud-free mosaics, it's not useful for us. You still have holes and gaps. Then Alex got on board and he started building, processing geomets for Sentinel-2, Landsat, and also Sentinel-1, so, which is what we use as a foundation for all our ML products. Lots of products in development, won't talk about it. We also do a lot of capacity building in countries. This year alone, we have done 6 workshops in 6 countries with 30 agencies with 71 participants. Almost 50% of them were female, which is very exciting because normally when I started doing capacity building 10 years ago, it's very rare to see one or two females in the audience, but these days we almost always have equal or more females in this very highly technical workshops at observation space. Again, probably just want to highlight that teaching at observation is not easy. Sometimes when you go and you train people, you have to teach them Python and also at observation, so we build a lot of abstraction libraries to like really simply, easily do NDVI land cover with 1 or 2 lines of code. And probably last slide. So we are not just with the countries, we are also working with Geoscience Australia, CEOs, NASA, NOAA. They are part of our governance board. We meet every quarter for them to guide us where it should go. And I think I'm done. Thank you.
Thank you, Sachin. Round of applause, please. Does anybody have any questions for Sachin? We can have mics run to you. Yes? No? Okay. If not, then I'll ask a question. Sachin, what are some of the unique challenges you faced in building a cloud-native geospatial infrastructure, specifically tailored to the Pacific region?
Well, again, like I said, most of the data sets are hosted in either Europe, Eastern Europe, that's where the central data sets are. The Landsat data sets are in the US, West region. So when we build platforms and we host it, even in the cloud, in the Pacific region, there's a lot of like bandwidth cost involved in terms of ingressing data. So we have to be mindful of that. The other challenge that we face is internet. Not all countries have very stable internet connectivity. So yes, we can do a lot of high-end work with very like minimal bandwidth, but still it can be a bit of a challenge because like what we have found is like when we develop products, the users also want to download it for their local analysis. Yeah, so that's one of the challenges, but I'm pretty sure Alex has more.
Precisely in related to what you just said, the World Bank and other donors has been investing a lot in underground cables and so on. Have you seen a change on that? What's happening with that project of improving reliability of internet? And are there ways around hosting data more local or something, or images of the data or something?
Yeah, so internet is good. It has improved a lot in the last 10 years. We have few countries with 5G now. But again, most of the ministries are based in a very remote area, so they're not entirely connected to very good internet. So when we do workshops in a fancy environment, they can access it, but when they actually go back to the home office, they have challenges. The other thing I want to highlight is we do lack a lot of data in the Pacific, especially when it comes to Sentinel-1. So that's why we can't do things like flood detection and flood monitoring. We have been talking to ESA and NASA about that because by the time they reach the Pacific, the sensors are full, the memory is full, so they switch it off. So we have very minimal Sentinel-1 coverage in the Pacific, and we also have a lot of data gaps. But again, these are long-term challenges that we'll solve. Yeah.
Hello. Very impressed of what's been shown here and the data that's within the Pacific. I'm from Papua New Guinea, and imagery is one thing that we really need for a lot of analysts. How can we get access for this? Is it for public use?
Yeah, everything is in the public domain. You can download any of our products using a number of services, WMSs and Stack and whatnot. We actually hold workshops how to download all the products and images. Nothing's restricted.
Okay, thank you, Sachin.
Thank you.